Example, permutations number 1. The final heat of Olympic swimming events features 8 swimmers or teams of swimmers. How many different podium placements, that is, first place, second place, and third place, are possible? Now, this situation represents a permutation because there are a fixed number of teams, or swimmers in this case, that can be selected from, and there are a fixed number that are being chosen from that list. In this case, there are 8, and we are choosing 3 of them. Now, in particular, we pay attention to the fact that in permutations, the order matters. The order matters. Because if you swap the person who has first and second place, this is now an entirely different situation. All right. So this is a permutation, and so what I'm going to write is 8p3. 8 groups, we are choosing 3 of them where this is a permutation, where the order matters. Now to find this value, I'm going to go over to Class Calc. I'm going to pull that up. And on my page, from any menu, I can choose Stat. So I'm particularly on the scientific calculator. I will choose Stat. And there's an option here that is NPR. NPR, I will choose that. And then I'm going to end up inputting NPR, and then in the parentheses, 8, 3. And this outputs 336. So 8 teams chosen 3 at a time. Where the order matters, there are 336 different podium placements that could occur. Example, permutations number 2. Find the number of permutations of 12 objects taken 3 at a time, or compute 12p3. So 12p3, we don't have to interpret this, we just need to go to our calculator, go back to Class Calc. I will, from my scientific calculator, I'll choose Stat, NPR, and I'll input 12, 3. NPR 12, 3 is 1,320. So if you have 12 objects taken 3 at a time where the order matters, there are 1,320 combinations. Example, permutations number 3. A school board consists of 9 members. Each year, the board must elect amongst themselves a president, vice president, secretary, and treasurer. How many different permutations can be formed? So first, this is a permutation. We are told that in the question, but this is a permutation because the order matters. If I take the person we choose as president and the person we choose as treasurer and replace them with each other, we swap their places, we now have an entirely different set of officers. So the words that I often look for, I look for things that have position or place. So position is the best word there. The positions are president, vice president, secretary, and treasurer, and it matters if we replace 2 people, if we exchange positions. Places, I typically think of first, second, and third place. Those are actually positions. So we look for things with positions. Those are permutations. The order will matter in those positions, or in those situations. So we have 9 people. We have a permutation because the order matters, and there are 4 that we are selecting. So 9p4. So if I go over to Class Calc, and I again go to my scientific calculator, choose Stat, choose NPR, 9, 4, I get an answer of 3,024. So there are 3,024 different permutations that can be formed.